Yeah, let's start the class. Okay. So today we are going to discuss about Fourier series. So chapter 4, we are going with chapter 4, that is Fourier series. What happened? Just wait. Fourier series. Okay. So we are going to discuss Fourier series. So what is the meaning of a Fourier series? Write it down. Fourier series expansion. Any waveform can be represented in the form of sinusoidal waveform. That is the meaning of a Fourier series. Okay, any kind of a waveform. This is your triangular waveform. So this can be represented into a sinusoidal waveform. A multiple number of sinusoidal waveform. Summation of that multiple number of sinusoidal waveform will give you that particular waveform. Means even if we have this kind of a periodic waveform, even if we have this kind of a periodic waveform, square waveform, so everything can be represented in the form of sinusoidal waveform. So that's why Fourier series are very important. And if we'll get the if we'll get this value, if we'll get this kind of a value, this kind of a expansion, that means, see, this is your triangular waveform. So the first sinusoidal waveform, we call it as a fundamental waveform, fundamental frequency, whatever. The second, then the second you are getting is your harmonics. After that you are getting the harmonics. Okay. So there will be a first harmonic, second harmonic, third harmonic. It's like that. Okay. So what is the meaning of a Fourier series? Fourier series is used for periodic signal. Okay, first of all, write it down. Fourier series, Fourier series expansion is used for periodic signals. Okay, and in Fourier series signal is expanded in terms of harmonics, which are sinusoidal and orthogonal to one another. Okay, what we do in a Fourier series? In Fourier series expansion, expansion is expanded. Fourier series, write better to write like this. Okay, Fourier series signal. Okay, better to write like this. Fourier series signal is expanded in terms of its harmonics, which are sinusoidal and orthogonal to one another. Okay, with the help of Fourier series it is possible to calculate what we can calculate. So write it down. with the help of with the help of Fourier series it is possible to calculate, means its application is this. So why we are doing the Fourier series? For calculations of these things. And what is the calculations? Harmonics contained contain in the signal. Harmonics means what? It's a basically impurity. Okay, phase contain at each harmonics. Okay, phase means angle. Some angle will also be there. Power contains of a harmonics. Power contain of a harmonics. And total power of the signal. Total power of signal. And auto correlations of the signal. Auto correlation of signal. So but there is some conditions. So what is the condition for a Fourier series expansion? So see, we can calculate the harmonics contained in a signal, we can calculate the phase contained at each harmonics, power contain of a harmonics, total power of the signal, auto correlations of the signal. But there is some conditions for Fourier series expansion. Write it down. Condition for Fourier series expansion. Okay, so what is the first condition? It's known as Dirichlet condition. Dirichlet, Dirichlet condition. Okay, so what is the meaning of a Dirichlet condition? Signal should have finite number of maxima and minima. Signal should have finite number of maxima and minima. Okay, over the range of time period. Over the range of time period. And what is the meaning of maxima minima? See, if you are having a signal like this, periodic signal. Okay, this is a periodic signal. What is this? This is maxima and this is minima. Okay, finite number of maxima and minima means your one time period. So one time period is up to here only. Okay, so you have one maxima, one minima. So finite number is coming. Okay, so first condition satisfied. So Fourier series expansion is possible. Fourier series expansion is possible. Okay, now example 2. This is example 1. And if I'll give you a particular another example. So see, you have a signal like this, then it's going, then again it's starting like this, then again it's getting like this, then again it's starting, it's like this. Similarly, these things are happening in this side. Okay, so this kind of a signal is not having finite number of maxima and minima. No finite number of maxima and minima. This is the time period t naught. Okay, this is the time period. So in the particular time period, we are not getting the finite number of maxima and minima. So Fourier expansion is not possible. Fourier series expansion is not possible. So this is the Dirichlet conditions. Okay, the second condition is, this is the Dirichlet first condition, and the second condition is signal should have finite number of discontinuities. What is the meaning of discontinuities? Signal should have finite number of discontinuities. So what is the meaning of finite number of discontinuities? So this is t, this is x of t. Okay, so this is t, this is x of t. So if I having a square pulse, so a square pulse is going like this, like this, like this, it's going like this. Okay, and it's going like this, like this, it's going like this. Okay, so how many discontinuities it's have? So see, 0 to 0 1 2 means this is one time period. Okay, so continuous means it's the signal is going like this. Whenever the sharp point will come like this, one discontinuity like this. Okay, one discontinuity at this point, then it's going, then again sharp point is coming, so second discontinuity, third discontinuity. So you have to say like this. But if the signal is like this, no discontinuity. Okay, so this is the discontinuity. Okay, so how many discontinuity is there? If you will see, means the signal is starting, means like your signal is starting like this. So one discontinuity. Okay, or see, it's going like this, we are moving like this, so this is one discontinuity, and we are going like this is second discontinuity. So how many discontinuity is there? Means it's moving like this, so one discontinuity, second discontinuity, so two discontinuities. So this kind of a signal is possible, means over the range of a time period, signal should have a finite number of discontinuities. So in this particular time period, we having a finite number of discontinuity. Even it is 0, then also it will be satisfied. Okay, so signal should have finite number of discontinuities. Write it down. Over the range of time period, and the size of discontinuity should be finite, and the size of discontinuity, so this discontinuity is finite, and the size of discontinuity should be finite. Okay, so signal should have finite number of discontinuities over the range of time period, and the size of discontinuity should be finite. Okay, so I will give you one particular example, means this final Fourier series expansion is possible. Okay, example 2, that was the first example. Now you having a signal like this. See, your signal is like this, like this, like this, like this, it's going like this. Then again the signal is starting from here, it's going like this, like this. It's starting from here, it's going like this, like this. So how many discontinuities is there? It's not finite, it's like this. So many discontinuities is there. So Fourier series expansion not possible. Not possible. So this side also it's repeating the same thing. Okay, so that is the condition of the Fourier series expansion. Signal should be absolutely integral. Third condition is that, write it down. Third condition, signal should be absolutely integrable over the range of time period. So this is time period, write it, time period. Okay, so that is means you are getting a finite value x of t. Integration of x of t into dt should be lesser than infinite, So these three conditions you need to remember. Like for example, I am giving you for this. Suppose you have a signal like this. This is 0 to t naught by 2. It's going like this. Okay, this is the signal. So x of t. So if you will find the time period, means this in a one time period, if you want to find the area, you will get this particular integration. So this particular area will come. So finite value we are getting, integrations finite we are getting. So this Fourier series expansion is possible because finite integration over a time period t naught. So Fourier series expansion is possible. Why possible? Because we are getting absolute integrations, means finite area we are getting, because we are getting finite area, that is absolute integrable. Okay, so this is the, and if I'll give you a second example 2, x of t is equals to tan t. So this is, in this will not get the Fourier series expansion because will not get finite area, because tan graph will go upside, means infinite value will come. Okay, so that's why Fourier series of tan t is not possible. Okay, so discrete conditions are sufficient but not necessary. So what is the meaning? Means if discrete condition is also satisfied, means for the signal which we want to express in a Fourier series, so there should be a discrete conditions must be satisfied, but it's not necessary condition. Okay, discrete conditions are sufficient but not necessary means okay. So there are some signal, means some signals are there Fourier series expansion possible, but Dirichlet condition is not satisfying. Example, means even the Dirichlet condition is not satisfying, we can express the Fourier series, but there is a kind of exception. So what is the exception signal? Exceptions are here. Okay, like this kind of a signal. Okay, you are getting, means you are getting the infinite value. See, the value is infinite at magnitude, because delta t naught to t naught minus t naught. So we are getting a impulse. Okay, minus 2 t naught. So it's this kind of a, this is your delta t value. So this kind of a signal is we can express the Fourier series, but Dirichlet conditions will not satisfy in this. Okay, similarly, example 2, if we'll do upside downside, upside downside, upside downside, so see, this infinite value we are getting here, we are getting the infinite value, we are getting the infinite value, but the Fourier series expansion is possible for this signal. Okay, now write types of Fourier series expansion. Types of Fourier series, types of Fourier series expansion. So what is the types of Fourier series expansion? Your first type is trigonometric Fourier series expansion. Trigonometric Fourier series expansion. Okay, so x of t is can be expressed as a naught plus summation n is equals to 1 to infinite an cos n omega naught t plus bn sin n omega naught t. So this is one expression of the Fourier series expansion. Okay, so this is one of the expansion of the Fourier series expansion. Okay, so now if I'll say what do you mean by a naught value? A naught particularly means denotes the DC value, DC or average value of signal. Okay, and how can we find the a naught value? A naught can be simply find as 1 upon time period x of t into dt. So a naught can be find like this, means area, absolute area. And what about an value? An is nothing but 2 by t naught time period x of t cos n omega naught t to dt is coming. What about bn? 2 by t naught time period x of t sin n omega naught t to dt. So this formula you need to remember. This is a very important formula. Trigonometric. So x of t is a naught plus summation n is equals to 1 to infinite. Overall, this all are in bracket. an cos n omega naught t plus bn sin n omega naught t. So what is the meaning of a naught? A naught is the DC value. So DC value, what the DC value you are getting the signal. So that part will come. And what about this? an is nothing but 2 by t naught x of t cos n omega naught t. Okay. And what about bn? Bn will be 2 by t naught x of n 2 by t naught x of t sin n omega naught t into dt. So this formula you need to remember. And there is another way to represent that. Another way is known as complex exponential Fourier series expansion. And how we can represent complex Fourier series expansion? X of t is equals to summation n is equals to minus infinite to infinite cn e power jn omega naught t. That's it. What is c? C is your coefficient. Okay, what is the meaning of a cn? Cn is nothing but expression of a Fourier series coefficient. How can we? So this is your cn, and cn value is nothing but 1 by t naught x of t e power minus j n omega naught t into dt, time period t naught. Okay, so this is the meaning of cn. Okay, now even if you will put suppose I am putting n is equals to 0. So what the c0 value will get? 1 upon time period t naught x of t e power n is equals to 0, so x of t into dt. So this is equals to what? This is your a naught only, average dc value of signal. Okay, like that if you will put suppose you are putting, yeah, so for checking conjugate symmetric or not, suppose your signal is f of k is f conjugate of minus k. You are checking this part if you want to check, means like, see, now if I'll put n is equals to minus n, what I will get? C of minus n 1 upon t naught x of t e power j n omega naught t into dt. This is my equation 2. So what the things has been changed, means the rest of the things are same only, but here I am not getting negative. Instead of negative I am getting plus. Okay, and even if I'll take the c of minus n conjugate, if I'll take 1 upon t naught x of t, so conjugate means j will become minus j e power minus j and omega naught t. So this is equation suppose 3. So your equation 3 is coming to equation 1 only, equation 1 only. Okay, yeah. So what is the meaning of this? The conjugate will be here also, sorry, yeah. What is the meaning of this? C of minus n conjugate is nothing but 1 upon time period x conjugate of t e power minus j and omega naught t into dt. So what you had understood from here, if so assume conjugate means like if I am assuming c conjugate of minus n is equals to c of n, if I am assuming like this, so what will happen? 1 upon time period, I am writing this value. So 1 upon time period integration x conjugate of t e power minus j and omega naught t is equals to, I am supposing, I am not saying that it is correct. Okay, so 1 upon time period integration x of t e power minus j and omega naught t into dt. So here also dt. So what the things will get cancel out? This part also, integration also. So what you are getting? X conjugate of t is equals to x of t. Okay, so and where it is possible, x conjugate of t is equals to x of t, always possible in real signal. Okay, see 5, if you are taking x of t is equals to 5, so x conjugate of t will also be 5. But if you will take x of t is equals to 5 plus j, so x conjugate of t is equals to 5 minus j. So these things is only possible in a real signal, means if you are getting in a real signal c of n will be equal to c of minus n conjugate. So for a real signal exponential Fourier series coefficient will be conjugate symmetry. Write it down. For real signal exponential Fourier series coefficient will be conjugate symmetry. Coefficient will be, but valid only for real signal, not for imaginary signal. Coefficient will be conjugate symmetry. So suppose In example 1 they had given you some signal like this. See, x of t they had given, it's a periodic signal, and they had given c of n value is n square plus j sine n. So this is your real signal. Okay. So if this is my c of n, what will be my c of minus n? Because we know that in a real signal c of n is equals to c of minus n conjugate. So if I am taking c of minus n conjugate, I am getting n square plus j sine n. So if I'll cancel this conjugate, so I will get c of minus n is equals to n square minus j sine n. And if I cancel this minus, then I will get n square sine of minus n will be minus, so plus j sine n. So we got the value of a cn using that property, because in a real signal c of minus n conjugate is equals to c of n. Okay, now suppose you have a x of t signal, summation now you have a x of t signal, that is summation minus infinite to infinite cn e power j n omega naught t. You want to find the Fourier series of this. So if I am putting n is equals to minus 1. So at n is equals to minus 1, what value we will get? So we have this formula. If you will apply this formula, so what value you will get? We will get dot 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 plus c of minus 1 e power minus j omega naught t plus c naught plus c of minus 1 plus 1 e power j omega naught t. We are getting like this. Okay. And suppose your cn value, earlier questions they had given n square plus j sine n. They are given like this. So c1 is coming how much? 1 plus j sine 1. c0 is coming 0. c2 is c1 c of minus 1 is coming as 1 minus j sine 1. So see this 2. 1 is c of n is equals to 1 plus j sine 1, and 1 is c of minus 1 minus j sine 1. If we'll take the conjugate, we'll get the same result. So c of n is equals to c of minus 1 conjugate, because this is the real signal. So in the real signal it's possible. So if you will put the things like this, so I am getting c of minus n is equals to 1 minus j sine 1. Okay, 1 minus j sine 1. So and this will be e power minus j n omega naught t. N is equals to minus 1. So e power j n omega naught t. So if n is equals to minus 1, so minus j omega naught t. So c naught value will come 0. Why 0? Put the value in this 0. N is equals to 0. Sine 0 is 0. So 0 is coming. And if you will put plus 1, so you will get 1 plus j sine 1 e power j omega naught t. And combine the result and see this, how much you are getting. So you are getting one side is e power minus j omega naught t plus e power j omega naught t. One side is minus minus j sine 1. Yeah. And yeah, and it is e power minus j omega naught t, and another is j sine 1 e power j omega naught t. Okay, so we know that if I'll multiply and divide by 2, so this meaning of this is if I'm multiplying 2 and divide by 2, so the meaning of this is cos omega naught t, right?
Cos omega naught t.
Yeah, cos omega naught t. Okay, so if you will use this, how much, what you value will get? 2 cos 2
So
cos
cos omega naught t.
2 cos omega naught t. Okay, and here we have j sine 1 common. Okay, so I'm taking minus j sine 1 common, multiplying 2. So what the value I will get? E power minus j omega naught t minus e power j omega naught t divided by 2. Okay, so j I am taking downside and 1 j I am taking upside. So 2 cos omega naught t, so j square will get
Plus
yeah,
sine.
no, minus will, it will become plus to 2.
Minus of minus plus.
Yeah, 2 sine 1.
Sine omega.
Yeah, and yeah, I have taken opposite directions. Okay, just let me correct it. So consider this as a positive, this as a negative, so it will be positive, it will be negative. Okay, so 2 cos omega naught t, so I will get minus sine 1 j square into 2, and this is nothing but e power j omega naught t minus e power minus j omega naught t divided by 2j. So this is the formula of sine omega naught t. Okay, sine omega naught t, we are getting sine omega naught t. So yeah, but I think negative will come. This will be positive. So we did some mistakes. Let's check it. 1 minus j sine 1 e power minus j omega naught t. Okay, correct. This is 0. 1 plus j sine 1, correct. So e power minus j omega naught t is there. Okay, plus e power j omega naught t. Okay, correct. Divided by 2, multiplied numerator and denominator by 2. Okay, correct. Then if we are taking minus j sine 1 e power minus j omega naught t. Okay, plus, okay, just tell me the formula. We have e power I theta is equals to cos theta plus j sine theta. E power minus I theta is equals to cos theta minus j sine theta. So then if we will add this, if we will add this, then it's fine. E power I theta minus e power minus I theta divided by 2j, we are getting sine theta. Okay, the formula is e power I theta minus e power minus I theta. That is correct. That means the formula we are getting, it's correct only. But these things will come positive. So e power minus j omega naught t plus e power j omega naught t divided by 2 minus j sine 1 e power minus j omega naught t plus j sine 1 e power j omega naught t. Okay, then if we are taking common j sine 1, okay, if we are taking j sine 1 okay, correct only na, e power, then j we had divided and multiplied upper side. Okay, just try this part is not coming correctly. take minus j sine 1 common. So if you are taking minus j sine 1 common, how much you will get? Or if you are taking simply j sine 1 as a common, you are getting e power j omega naught t minus e power minus j omega naught t, right? And if I am dividing this 2 upside and 2 upside, there j is also coming. And
Sir, first one is minus, sir.
which one?
Minus e power j omega naught t.
Minus e power j omega naught t. How? See, the equation is like this. Okay, you understood? Means like, see, equation is x of t is equals to summation n is equals to minus infinite to infinite. This is the formula of the Fourier series. Okay, this is the formula of the Fourier series. And the value of a cn is given like this. Okay, cn they had given cn is equals to n square plus j sine n. Okay, so I am taking means see, so x of t is equals to summation n is equals to minus infinite to infinite, and we are having the value cn e power j n omega naught t, cn e power j n omega naught t, and the value of this is my, and the value of a cn they had given n square plus j sine n. Okay, these things they had given. What I am telling, if you are taking c of 1, you are getting 1 plus j sine 1. Okay, dot 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 part 1. Okay, c of minus 1, if you are taking, how much you will get? 1 of j sine of minus 1. So c of minus 1, how much you will get? 1 minus j sine 1 only, because sine of minus theta is equals to sine theta. Okay, so and if you will taking c of n is equals to 0, so you are getting 0 plus j sine 0. So 0 is coming, means this value is coming like this, and we are stopping at minus 1, then at 0, then at plus 1, and we are substituting overall value. So if you will put the value of a c of minus 1, what you are getting? 1. Okay, c of minus 1, 1 plus j 1 minus j sine 1. Okay, so 1 minus j sine 1. This is my one of the value, 1 minus j sine 1. And because this is at minus 1, so this will become, n will become minus 1. So e power minus j omega naught t. Okay, minus 1 value is done. Then 0 was coming. Then again 1 we had substitute. So we got 1 plus j sine 1. And the value was e power j omega naught t. Okay, rest of the value we are not putting. Okay, plus 2, minus 2. We are just taking for this. So now if I am taking, see, carefully take the common. So if I am taking the common, e power minus j omega naught t plus e power j omega naught t. This part and this part we took. Okay, now the rest of the part what we have? Minus j sine 1 e power minus j omega naught t plus j sine 1 e power j omega naught t. We have this much part. Okay, so I am dividing 2 here, dividing 2 here. So the meaning of this I know. The meaning of this is 2 cos omega naught t. The meaning of this is this. Okay, now I need to make in this form e power theta, e power I theta. What was the formula, guys? E power I theta minus e power minus I theta
E power minus I theta by 2j.
By 2i. Yeah, that is the formula of a sine theta. So we need to get this formula. Okay, So we have a minus j, right? So we have take first sine 1 as a common. Sine 1 as a common. Now we have a minus j e power minus j omega naught t plus e power j omega naught t. J is also there. Okay. So what we can do, we need to make it like this: e power I theta minus e power minus I theta. So if we'll take j as a common, simply j as a common, 2 cos omega naught t, I am taking j as a common, simply j. So j sine 1. So we are getting e power j omega naught t. This I am writing this side, and e power minus j omega naught t. Correct? Up to here it is correct. Okay. Now if I am multiplying this 2 here, this 2 here, now j is, I am multiplying 1j here and j square is there. So 2 cos omega naught t minus 2
minus 2 sine omega t.
sine 1 into
1 sine
sine.
omega.
So minus will only come then. Yeah. So we did everything is correct only. So minus will come only. Okay. Yeah. The answer is right only. It's not wrong. So minus we are getting, and the rest of the terms I didn't did. Rest of the terms leave it like this. Okay. So we are getting something like this: plus 2 cos omega naught t minus 2 sine 1 sine omega naught t plus dot. Okay. So this is your what? This particular terms is what? This is your overall terms is your x of t, right? Your x of t. So in this overall x of t, you will get j term. No, you won't get j term. You won't get j term. Why so? Because anywhere, any way you will put the values and all, you will convert this into the form of a cos omega naught t sin omega naught t. So this kind of a signal is what? It's a real signal, right? Real signal. And we discussed earlier, in a real signal what's happening? In a real signal, what is happening? C of n is equals to C of minus n conjugate, right? So what was the C of n value? N square. See the question: n square plus j sin n. N square plus j sin n. So C of n means if I am putting C of 1, so I am getting 1 plus j sin 1. If I am putting C of minus 1, I am getting 1 minus j sin 1. Sign of minus 1 will become. But if I am taking the conjugate of this, so I will get the same result. C of minus 1, the conjugate, I will get the same result, 1 plus j sin 1. So this is coming equal to this, and this is possible in the real signal. Okay, so that's why after the expansion and all, this signal will be real only. You can check it for C of 2. N means whatever this is your negative side value, this is your positive side value. So 1 you are putting, so you have to check for minus 1. You are putting 2, so you have to check for minus 2. So C of 2 will be 4 plus j sin 2. C of minus 2 will be 4 minus j sin 2. If you will take the conjugate, C of minus 2 conjugate, you will get 4 plus j sin 2. And if you will solve this C of C2 plus C of minus 2 like that, what we did, we will get the cos omega naught term and sin omega naught term. So this is the real signal only. Okay, got it? Understood, guys?
Yes, sir.
Okay. So what you had understood from this, for a real signal, exponential Fourier series coefficient will be conjugate symmetric. This is very important. Okay, this part is very important. For a real signal, exponential Fourier series coefficient will be conjugate symmetric. And if they had given you the Cn term like that, okay, they had given the Cn term like this, Cn is equals to n square plus j sin n, so you have to check by putting 1 2 3 and minus 1 minus 2 minus 3. If they are giving the conjugate result, then then you can directly say that the signal is real signal. Okay, and in the gate examination they are asking like this. They will give you the term and they will ask the is the signal is a real signal or imaginary signal. Okay, and if you are not getting c of n, if you are not getting c of minus n ka conjugate, then this signal will not be a real signal, it will be a imaginary signal. I hope this part is clear for you. I hope you grasp the concept what I wants to say you. Okay, now they had given you a one particular question is this is one particular question. Okay, so x of t and your signal is like this, minus tau by 2 to tau by 2. Then again same thing is coming. This is your t naught part, means this is your t naught part, this is your t naught part, the same thing is coming, t naught part, and the value of this is your a naught, and they are asking the Cn. What is Cn? Using this particular diagram. So I told you the formula of a Cn. Cn is what? 1 upon time period minus t naught by 2 to plus t naught by 2. Okay, x of t into e power minus j and omega naught t into dt. So this is the, so if you will put in the form of equation, what you will get? So minus t naught by 2 is total time period is t naught only. I am taking t naught. Okay, so minus t naught by 2 is minus tau by 2 to plus tau by 2, x of, and what is the x of t value? A naught value we are getting. X of t value is a naught we are getting, a naught, and this is e power minus j and omega naught t into dt. Okay, if we'll solve this, if we'll solve this, a naught divided by t naught, and the integrations will be e power minus j and omega naught t. Okay, so minus j and omega naught will come downside, minus tau by 2 to plus tau by 2. So a naught and omega naught t naught minus j, I'm taking this minus j as a plus j upside. So 1 of minus j is equals to plus j only. Yeah, okay, because 1 upon j is minus j, so minus 1 upon j is plus j, so I am taking minus j as a plus j. Okay, upside, and put the limit, what you will get? E power minus j and omega naught tau by 2 minus e power minus j and omega naught tau by 2. Correct. So yeah, so minus minus will become plus. So minus j and omega naught tau by 2 you are putting, then you are substituting e power j and omega naught, so minus minus will become plus. Okay, take like this an and omega naught t naught, and take minus as a common, means you will get minus j. Okay, if you will take the minus common, so e power j and omega naught tau by 2 minus e power minus j and omega naught tau by 2. Okay, so this terms we can break Okay, how we can break? Again bring this in downside because breaking is required. So e power j n omega naught tau by 2 minus e power minus j n omega naught tau by 2. So this is j, 2 multiplied here and 2 multiplied here. So we can write in the form of 2a naught divided by n omega naught t naught. This is sine n omega naught tau naught by 2. Okay, this is sine theta. So this is your theta. This particular is your theta. So we are getting this equation, and omega naught t naught will get cancel out. How so? Omega naught t naught will get cancel out. Or anything I am missing? Let me check it. Yeah guys, everything we took na. Okay, so we got this particular equation. Okay, so omega naught, what is the meaning of omega naught? Omega naught is equals to 2 pi f naught. So 2, and f naught is reciprocal of 1 by
1 by t.
So this will get, we can write like this, 2a naught divided by n into 2 pi, right? Sine n omega naught tau by 2. Okay, so this will get cancel out. So a naught by n pi and sine n omega naught tau by 2. Okay, what is the sampling formula? What is the sampling formula? Sampling signal, I told you na, sampling of t can be written as sine pi t upon pi t, right? If we will check the sampling signal, basic signal, in basic signal only, I thought you not. Yeah. So guys, yeah, sampling signal, I thought you right. Sampling, and not getting here. So I need to check. Okay, that is the formula. Okay, sampling signal formula is this only. So sine pi t upon pi t. So see, if we want to write this in the form of a sampling signal, if we want to write this particular in the form of sampling signal, so what we need to do? We have a naught, we have sine n omega naught tau by 2 divided by n pi we have. Okay, and even if we want to break this in sine n omega naught 2 pi f, we can write 2 pi f naught, or leave it like this only, okay. Okay, we will convert this in the sampling signal later. Just you can write the answer like this also, but in the exam they will give you means sometimes they are given, they are changing this form into the sampling or sync function. So first revise the sampling function and sync function, then you can convert by dividing dividing this particular number. Okay, so you can do it later, these things. So I'm getting confused because I didn't check that sync and sampling function. So means maybe sync t is sin pi t by pi t. I'm getting confused in this. Sampling t is sin t upon t. So you just check it. I thought you these things. So you just check it. What was that sync and sampling function, and according to that, you can change this result by dividing this particular things and multiplying this particular thing. Then the final answer, if you are writing in the form of sampling, you will get a naught tau by t naught sampling and omega naught tau by 2, the final answer. And you can leave up to this part also, it's up to you. Okay, so this function is, we got the question was find the value of a cn, and we got the value of a cn. Okay, we got the value of a cn. And even if this is a sampling function, so your graph will be look like this. Your graph will be look like this. Okay, so if this is a sampling function, means this value, this particular is at 1, this particular is at -1, this particular is at -2, so this particular is at -2, means c of 1 and c of this is your c of -1. So c of 1 and c of -1, if you are getting like this, means same magnitude, so c of 1 is c of -1 conjugate. Okay, so this thing means the result is this cn. Because of this cn, you can say that x of t is your real signal. Okay, by plotting this graph. Okay, don't means if you are getting confused, so just go and revise the sampling and sync functions. Okay, then you will not be able to confuse this kind of things. Okay, and the process is this only, to find the waveform and all. You just need to put the things in this equation. C of n is equals to 1 by t naught minus t naught by 2 to plus t naught by 2 x of t and e power minus j and omega naught t into dt. X of t value is this a naught, and the integration we are doing from minus tau by 2 to plus tau by 2. So minus tau by 2 to plus tau by 2. What is the time period? 1 by the time period is tau only, means you can write instead of a t naught as a tau, but I am preferably writing t naught. Okay, and if you will integrate this after the integrations, you are getting this function. Okay, so you can break this, or even you can, if you don't want to break this, you can write this particular thing as a naught and omega naught t naught by 2 like this, and t naught by 2 is nothing but a naught and omega naught tau by 2 only. Okay, because t naught is equals to tau, and this is your sine and omega naught tau by 2, and the same functions you are getting down. So sine t by t, so you can directly write in the form of sampling functions, or whatever your wish, you can write in the form of sampling function or a sync function. It's up to you. Now if we'll go for you have a signal like this, a question, find c of n for signal x of t, and the x of t signal is given like this: summation n is equals to minus infinite to infinite delta t minus n t naught. Okay, so if you will put these things in a graph, what you will get at t is equals to 0, you will get one infinite function x of t. At t is equals to, at n is equals to 1, means at t naught value you are getting the infinite function. So at t naught you are getting the infinite function, at 2 t naught you are getting the infinite function, at minus t naught you are getting the infinite function. So this is your infinite value, but area is 1. Area is 1. Now they said that find the value of a Cn. So Cn is nothing but 1 upon time period minus t naught by 2 to plus t naught by 2. X of t e power minus j and omega naught t into dt. Okay. So if you want to break, means if you want to solve this particular integration, what you will do, yeah, so you can solve it easily. So minus t naught by 2 to plus t naught by 2, see, this particular is minus, means we are taking from minus t naught by 2 to plus t naught by 2. So I am considering this part and this part. So minus t naught by 2 to plus t naught by 2. So what is the value you are getting? See, we can take from this to this also, but in this two impulse is coming, so it will make a confusion. The problem will be very difficult to solve. So better to, like what we are saying, see, if you have a sine function like this, so you can take a time period from here to here also, correct, or from here to here also, it's up to you. So I am taking my time period from here to here. Okay, means the signal is repeating from here to here, then here to here, then here to here, then here to here, and I am solving. And in this particular functions we are only getting one impulse function. If you will take from here to here, you will get confused either to take this one or to take this one. So better to break this in this form, minus t naught by 2 to plus t naught by 2, 1 by t naught. So 1 by t naught minus t naught by 2 to plus t naught by 2. So I told you, this is minus t naught by 2 to plus t naught by 2. X of t is delta t e power minus j n omega naught t into dt. I told you that the formula of this integration minus infinite to infinite delta t x of t is equals to x of 0, means whatever the t value, or minus infinite to infinite delta t minus a x of t, so the answer will be x of a. So according to this formula, just go and revise the formula if you are not recalling this formula, this kind of a formula, and you will get 1 by t naught, the value will be e power minus j n omega naught 0 according to this formula, because t value t minus 0 is there, so we need to put t as a 0. So what the value we are getting? We are getting 1 by t naught only, c of n value. What the answer? This is my answer, c of n. So c of n means, and in the graph how you will represent c of n? C of n, it is like this, means we are getting like this, means this is 0, this is 1 2 3 4 5 6 7, minus 1 minus 2 minus 3 minus 4, discrete. This will be in a discrete form, not in the continuous form, and the all value will be 1 by t naught. So this is also a real signal. It is also a real signal. Okay, understood or not? Is this clear or not, guys? Prasanna, understood?
Yes, sir.
Okay. So this is the concept of, means you need to practice by yourself also. Okay, go and try this example and practice by yourself also, then only the things will be in a mind. Okay, so like this is your workbook problem. I didn't share the signal system workbook now, I will share. So
No, sir, you didn't.
yeah, so this is one, means maximum workbook problem might solve in this video only, while teaching you the concept. So see, one question is workbook problem chapter 4, question number 7. So x of t is given, x of t is not given, ck value is given. So they didn't mention c of n, they had mentioned ck, minus 1 by 3 to the power k for k greater than or less than 0, and 0 for k less than 0. You need to find the value of x of t. Okay, this is the question. So x of t is what? X of t is summation of k is equals to minus infinite to infinite ck e power jk omega naught t. Instead of n, we are writing k. That's it. So we can break this form in like this: minus infinite to 0 c of k e power jk omega naught t plus 0 to infinite ck e power j n omega naught t. So this whole value will be 0 because ck value is 0 for k is lesser than 0. So all are lesser than 0. And here the k value will be greater than 0. So c of what you will get? C of 0 you will get plus e power j0 omega naught t plus c of 1 you will get e power j omega naught t plus c2 you will get e power j 2 omega naught t, like that. And you need to find the value. So what is the value? c0 will be minus 1 by 3 to the power 0. So minus 1 by 3 to the power 0 will be 1 only, and this will be 1. So 1 will come. Minus 1 by 3 to the power 1. So what you will get? Minus 1 by 3 e power j omega naught t. And here what you will get? Minus 1 by 3 to the power 2. So 1 by 9 e power 2j omega naught t plus minus 1 by 3 to the power cube. Plus will not come, minus will come. Minus 1 by 27. Minus 1 by 27. This is the gate question. E power 3j omega naught t. So it will be go like this. Right. It will be go like this. And guys, I hope you remember the infinite series formula. 1 plus minus 1 by 3 e power in aptitude. If you are solving the aptitude, you know. And if you are not solving, then it's a problem. E power 2j omega naught t, because aptitudes is important for gate also and placement also. 3j omega naught t plus dot 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 dot. So this is in the form of GP. Yeah, GP. So the summation of the GP will be, what is the GP you are getting? Means ratio. So ratio is minus 1 by 3 e power j omega naught t. If you will divide by this, the same ratio you will get. Minus 1 by 3 j omega naught t. If this is going like this infinite series, and if this value is lesser than, if your ratio is lesser than 1, means between 0 to 1, so you can apply a naught divided by 1 minus r.
1 minus a naught.
Yeah. So what is your a naught? 1. And 1 minus of r is minus 1 by 3.
1 plus 1 by 3.
Yeah, e j omega naught t. So what you will get? 1 divided by 1 plus 1 by 3 j omega naught e power j omega naught t. Right. Understood? And they had asked you at omega naught is equals to 2 pi by t naught, or we can write 2 pi by m, same thing. And if the t naught value is 1, what will be the x of t value if the t naught value is 1? So they had asked the b question, second question. So 1 divided by 1 plus 1 by 3 e power j okay. So at t is equals to 1, so you are putting 2 pi f and t naught, means it will get cancelled out. So means at t is equals to t naught, means at t is equals to t naught, they are not, it's t naught is equals to 1, it's t is equals to t naught. Okay, at t is equals to t naught, so what you will get, e power j 2 pi, right? Omega naught is equals to 2 pi f into t is also there, so they had say, and we can write 2 pi f as a t naught and to t, and at t is equals to t naught, what will be the value of x of t naught, they had said. So you will get 1 by 3 e power j 2 pi, so 1 divided by 1 plus 1 by 3, this can be written as cos 2 pi plus j sine 2 pi, right? Divided by, no, not divided, there will be no division, so cos 2 pi is 0, correct? No, no, not correct, it's 1, it's 1,
Sine
it's 1, and this will be 0.
sine value is 0.
Yeah, sine value will be 0. So 1 divided by 1 plus 1 by 3, so you will get 3 by 4, right? 3 by 4 you will get. You need to try one question by yourself, or the same thing you need to apply. So this is also one gate question. So question is like this: they had given x of t, ck value they had given 1 by 2 to the power k is greater than or equal to 0, and k lesser than 0, the value is 0. You need to find the value of x of t. So guys, can you do it? Means x of t, they had given the ck value is 1 by 2 to the power k. So what you will do, same formula you will apply. X of t is equals to summation k is equals to minus infinite to infinite ck e power jk omega naught t. Break this into form, and this will be 0, and then apply the same logic. You will get one AP form, GP form. Apply that GP, 1 divided means a naught divided by 1 minus r naught, get the result. So you can do these questions by yourself. So I am leaving this question because the same logic is that the same question, they change the number, that's it. So and they said that find the value of x of 0, means you are putting t is equals to 0, also what will the value, first find the value of x of t, and what will the value of x of 0. So the answer of x of 0 is 2, okay, and just you guys have to tell me the value of x of t.
So 2, sir.
Yeah, x of 0 is equals to 2, and x of t value, while solving the x of t value, you will get in the form of this kind of a equation, right?
1 by 1 minus
1 by 1 minus,
t form. T power k formula is 1 by 1 minus 2 e to. It's like
see,
1 by 1 minus 1
the
by 2 e
answer
power plus j
of
omega.
this is 1 divided by 1 minus 1 by 2,
1 minus 1 by 2 e power j omega naught. Sorry, j n.
not n, j omega naught t will come only. Why n? Because we already substituted the value. See, there is a any n is coming, no,
Yes, sir. Yes, sir.
no n will come.
No n.
Yeah, no n will
Omega
come.
naught.
Yeah, omega naught t. And see, and one question is like the second question means this question, x of t 2 plus 2 cos omega naught t plus sine omega naught t plus cos 2 omega naught t plus pi by 4. They had given, and they are asking you the value of a cn. How you will solve it? This very easy. X of t, so this 2 denotes c0. Okay, so write like this, 2 plus 2. How can we write cos omega naught t? E power j omega naught t plus e power minus j
plus e
omega
power minus j omega naught t.
divided by 2, right? How can we write this sin omega naught t? E power j omega naught t minus e power minus j omega naught t divided by 2j, correct? What about this? How can we write like this form? If you want to write these things, how can you represent this particular thing? So you can break it into two form, cos a plus cos b का formula, right? Cos a plus cos b formula. So cos pi by 4 cos 2 omega naught t minus sin pi by 4 sin 2 omega naught t. Now you can write it. Cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2. So 1 by root 2 plus 1 by root 2 is common, and write in the form of this, e power j 2 omega naught minus e power plus e power minus j 2 omega naught divided by 2, correct? And if you want to write this also, minus 1 by root 2 e power guys j 2 omega naught minus e power minus j 2 omega naught t is there, okay? So divided by 2j, correct or not? Okay, just tell me, this 2 is 2, okay? Now take the e power j omega naught common. This is getting cancelled out. E power j omega naught t as a common. So what you are getting? 1 you are getting. Anywhere e power j omega naught t is there? Yeah, this part is there. So plus 1 by 2j. Any other part we are getting e power j omega naught? No part. Okay, so these things done. Take e power minus j omega naught t common. So e power minus j omega naught t as a common. So what you will get? This as a 1 and this as a minus 1 by 2j. Any other part? No. Now take e power 2j omega naught t. So what the things you are getting? 2j omega naught t. 2j omega naught t. What the things you are getting? 1 by root 2. 1 by root 2. 1 by 2 root 2. 1 by 2 root 2. Minus 1 by 2 root 2 j. Anything else? Yeah. E power minus 2j omega naught t. Take common. What you are getting? 1 by 2 root 2 plus 1 by 2 root 2 j. Okay. So they had asked you find the value of cn. So c0 you are getting 2. What is the c1? C1 value is 1 plus 1 by 2j. What is the c2 value? C2 value is C2 value. Check the C2 value. C2 value is this. Because this is my n. This is my n. This is my n. The formula of a Cn, I hope you remember. Now only I told you. The formula of a Cn is, we are getting expression like this. Okay. So plus term means plus term denotes. So if this is my plus only, if this particular is my plus only, so the coefficient of this term denoting C of 1, right? Here some E is present who's having 0 as a power, so that means it belongs to C of 0. Correct. It's belong to, because e to the power 0 is 1 only, so I am assuming like this. So C of 0 is 2, and this particular part, this can be written as e power n j omega naught t, and n is 1, so this is your C1. This is minus 1, so this is your C of minus 1. This is your 2, so this is C of 2, and this is your C of minus 2. So you are getting what? You are getting the results. C of 1 is equals to 1. Just tell me, C of 1 is equals to 1 plus 1 by 2j. What is the C of 2? C2, what you are getting? 1 by 2 root 2 minus 1 by 2 root 2j. What about C of minus 1? C of minus 1, what you are getting? 1 minus 1 by 2j. And C of minus 2, what you are getting?
By 2.
1 2 root 2 plus 1 by 2 root 2j. Plus you are getting. Okay, what is the common thing? Means C of 1 is C of minus 1 conjugate. Correct? C of 2 is C of minus 2 conjugate. So what is the meaning of this? Your x of t signal is real signal. X of t signal is real signal. So C0 you got, C1 you got, C of minus 1 you got, C of 2 you got. Yeah. You got the result. And what about the other harmonics? So this is the overall signal. This is the overall signal. X of t overall signal is this. Okay. So no extra Cn term will be present. In this question, we will have only C0, C1, C of minus 1, C2, C of minus 2, C2. That's it. Other harmonics are 0, because we are not getting extra signal like continuous plus plus plus. Nothing is there. So whatever the things we got, we simply make in the form of result. So guys, are you getting or not? Means this kind of a concept. It's looking pretty difficult, but it's not that much difficult. It's very easy. We are just applying the formula. Are you getting or not? Prasanna, Priyanka, are you getting?
Yes, sir.
Okay. So here you can note it down. Note it down. Other sample of Cn is 0, because other harmonics not present. Okay. So okay, like us. Okay, I will tell you the things. See, if you are having something x of t, you will get some C of n value. Okay, with that you will get some angle also. So there is a different kind of a representations. Okay, so you are representing mod C of n value, like whatever the value you are getting at 1, 2, 3, minus 1, minus 2. And there is also a representation of an angle. What angle you are getting at 0, 3, means suppose you are getting pi by 4 angle. So you are representing pi by 4. You are getting some particular angle minus pi by 3. So you are representing like this. So C of n and angle of a C of n can be represented in this. So mod value you will represent in one particular graph, and angle value will represent in one particular graph. This is just a simple representation. Okay, so when we'll see the questions, then you will understand, but it's just for now, just look at this. Okay. Okay, now what we are going to see the relationship between an, bn and cn. Okay, so we already at the starting we had discussed the trigonometric function. Trigonometric. Okay, Fourier series. This is trigonometric Fourier series expansion. Okay, and this is complex exponential Fourier series expansion. Both will give you the same result. So what is the relation between this? Both will give you the same result. Okay, so we'll check the relations. Okay, write the topic name. Relationship between an, bn and cn. Okay, so guys, cn is nothing but 1 by 2 an minus j bn for any type of x of t. Means it's not depending upon the signal. For any type of x of t. Okay, and an is equals to 2 real of cn, and bn is equals to minus 2 imaginary of cn, and this is valid for only real signal. Valid only for real signal. Okay, while solving the example we'll understood. Valid for only real x of t. So see example 1. Your x of t signal they had given, that is real plus periodic. The signal is real plus periodic. And second case, imaginary signal but it's periodic. And third case, complex signal, neither real nor imaginary, both the combination is there, complex plus periodic. In that case you need to find means your an value is given, your bn value has given, this particular is given. Okay, and you need to find the value of a cn. How you will do it? Okay, so cn will be equal to 1 by 2 an minus j bn. No need to check it. This thing is applicable for all, every signal. Okay, this thing will applicable for all, but for imaginary means like yeah, valid for only real signal. Okay, so you can directly apply this because you need to find the an cn value. If you're having a an value and bn value and you need to calculate the cn value, you directly apply 1 by 2 an minus j bn. Okay, so see now in example 2, x of t, it's given as a real signal. It's given as a real signal. So what will be the cn value? Means cn in this question, okay, given value is Cn. You need to find the value of An and Bn. Okay, and this is your real signal. So what you will do, An will be 2 real of Cn, and Bn will be minus 2 imaginary of Cn. That's it. And how you will understand, okay, your C of n signal is given like this: cos n omega naught t minus j n j sine n omega naught t. It's given like this. C of n signal is given like this. It's given. And you need to find the an value. What you will do? So the an will be 2 real part. So real part is cos n omega naught t. And bn will be minus imaginary part. So imaginary part is this. Negative is also coming. So minus 2 minus sine n omega naught t. So you will get 2 sine n omega naught t. So like that we do. And see, and if an and bn both are given, see, this is my an, this is my bn. So what will be the cn? An minus bn, an minus jbn into 1 by 2. Same result you will get. Check it. So 2 cos n omega naught t minus 2 j sine n omega naught t divided by 1 by 2. So you are getting the same thing or not? So that is the concept. Example 3. In example 3, they had given, it's given x of t is not a real signal. Not a real signal. So if it is not a real signal, that means if x of t is not a real signal, means c of n is not equal to c of minus n conjugate, according to the previous concept, right? And you need to find the value of a and bn. Okay, so x of t, what you will do? Apply the formula. N is equals to minus infinite to infinite Cn e power j n omega naught t. So an will be 2 by t naught x of t cos n omega naught t into dt. Apply the formula, that's it. And bn will be 2 by t naught x of t sine n omega naught t into dt. If the x of t is not a real signal, then you only have to apply the formula. And from there you need to calculate an, bn or cn. That means basically this kind of a questions, when x of t is not a real signal, they are not asking in a gate, because it will become very difficult to solve this and tell the, they are asking the question like that only, where you can easily use this formula and tell the answer. So understood, guys? This part is clear?
Yes, sir.
Okay. Okay, if this is clear, then it's fine. Okay. Now write the very important concept. This is a very important concept. Write it down. make a table. Okay, real and imaginary, real and okay. It's very important. Your all question will be solved from this table. If the signal means this is your x of t part and this is your Cn part. Okay. If x of t is real, your signal will be complex conjugate. If x of t is complex conjugate, your signal will be real this side. And if you are having an imaginary signal, then you will have complex conjugate anti-symmetric signal this side. And if you have complex anti-symmetric signal this side, then you will have imaginary this side. And if you have real plus even signal this side, then real plus even will be this side also. If you have imaginary plus even this side, then imaginary plus even this side also. Okay. If you have a real plus odd this side, then this side imaginary plus odd will come. And if you have imaginary plus odd this side, then real plus odd signal will come. So if x of t value is real, like sin t, cos t, 2 or constant value, then the C of n will be complex conjugate. Complex conjugate means C of n is equals to C of minus n conjugate, right? And if this is your complex conjugate, if you are getting these things as a complex conjugate, means if your if x of t is equals to x minus of t conjugate, then means what I am saying, if this is your complex conjugate, that means x of t is equals to x of minus t the conjugate, then this signal will be real, means the Cn part will be real, like sin t, cos t, tan t. It's like these things will come. And if you having a imaginary signal, like suppose you having a x of t signal is sin t minus j cos t. Okay, if this kind of a signal is there, then you will get C of n is a complex anti-symmetric signal. And you know what is the meaning of a complex anti-symmetric? X of t will be x of minus t, the conjugate minus sign will come. Means here Cn value. Okay. So complex anti-symmetric means C of n will be minus C of minus n the whole conjugate. It's like this. And if you are getting this part as a conjugate, conjugate anti-symmetric means x of t is equals to minus x of minus t the conjugate, then you will have an imaginary signal in Cn. So Cn could be like this, cos n omega naught t plus j sin n omega naught t. Your Cn could be like this. And if you have a real plus
Then for imaginary, C of n is not equal to C of minus n conjugate, right?
Yeah, imaginary what?
That is minus of, okay sir, got it, nothing.
Got it. And if you have a real plus
Okay, sir, please.
real plus even signal, real plus even signal means cos, suppose the signal is cos t, so cos t is real also plus even also. So in the imaginary part also you will get the even signal, like that one. If you have a imaginary plus even signal, then in the Cn part also you will get imaginary plus even. So always remember, if even is coming, the same thing will come if even is coming. But when odd is coming, then real will become imaginary this side. When odd is coming, then imaginary will become real this side. So this is the simple example. So these things are very important, because by seeing the example only you can directly say means the option will be like four options, so they there will be a lots of confusion. So if you know this property, you don't need to solve in your mind, only you will directly check the answer, write the answer. Okay, I hope you got it, this concept.
Yes.
Okay. So rest all the topics actually means uh, tomorrow I am leaving for means for my one of my trip Sikkim I am planning. So for I think for 5 6 days I will not be able to take class. Okay, or even means if there will be a not a network issue in that mountains and all, so I will try to conduct the classes for you guys. Okay, or your examinations will be over at 13, right?
Yes, around 30.
So okay, so today is what? Today is 28,
28.
29, 30, 31. So up to what you guys can attend the class? You have a time for means when you
Up
when
to first, sir.
up to first. Okay. So 29, 30, 31. Okay. Then we'll continue the class after 13. Okay. Means at 13 we'll meet. Okay.
Yeah, okay.
So 13 or in between that if I'll get the time I will upload the videos. You can watch that. Okay.
Yeah, okay, sir. Sure.
Okay.